Welcome to The Explainer. Today, we're going to dive into the story of the most powerful and frankly terrifying creation in human history, the nuclear weapon. We're going to trace its journey from a wild scientific theory all the way to the world-altering force that has pretty much defined the modern age. This single reality has shaped global politics, our culture, and our collective anxiety for decades now. But how in the world did we get here? Well, the story doesn't start with an army or a politician. It begins with a single, brilliant, and in the end, a truly terrifying scientific discovery. So the path to the atomic age didn't start in some military bunker. Nope. It began in a quiet science lab with a revolutionary insight into the very fabric of our universe. Okay, so back in 1938, a German scientist named Otto Hahn made a discovery that would change everything. You could actually split the nucleus of a heavy atom. And here's the kicker. When you break that atomic bond, it unleashes a truly monumental amount of energy. This one process, nuclear fission, became the blueprint for the atomic bomb. Now, with the world already deep in World War II, this abstract scientific idea immediately became a top military priority. The race was on to turn this terrifying new energy into a weapon. And the speed of this race was just breathtaking. Think about it. In just 4 years, humanity went from a top-secret research project to successfully detonating a nuclear weapon, and then, only a few weeks later, using 2 of them to end a global war. So the first bomb they used was nicknamed Little Boy. It was a pretty simple design, really. Kind of like a gun mechanism that fired one piece of enriched uranium-235 into another. The collision would achieve critical mass and, boom, trigger that fission reaction. Now, to really wrap your head around the scale here, you have to understand the term kiloton. That's the power of 1,000 tons of regular explosives, like TNT. This one bomb was equivalent to 15,000 tons of TNT. A brand new, horrifying baseline for destruction had just been set. And then, just 3 days later, the second bomb, Fat Man, showed a stunningly fast evolution in the technology. I mean, this was a totally different weapon. It used a much more complex implosion design and a completely different fuel, plutonium. The jump in power was immediate and obvious. At 21 kilotons, it was way more powerful than the bomb from just a few days before. This incredible pace of innovation, well, it set a really scary precedent for the arms race that was about to define the next 50 years. But the end of World War II didn't mean the end of nuclear development. Oh no, not even close. It was really just the beginning. The Cold War kicked off a new era of weaponry with a jump in power so huge it's almost impossible to comprehend. Right, so in 1952, the U.S. detonates Ivy Mike, the world's very first hydrogen bomb. Now, this wasn't just an upgrade. This was a completely different and a far more terrifying category of weapon. This was a thermonuclear device. And with this new weapon came a whole new scale. We weren't talking in kilotons anymore. Now, we were talking about megatons. A megaton is 1,000,000 tons of TNT. At 10.4 megatons, Ivy Mike was nearly 1,000 times more powerful than the bomb that leveled Hiroshima. The very definition of destruction had been rewritten. So how is this incredible leap in power even possible? Well, it all comes down to 2 totally different nuclear processes. Atomic bombs, the A-bombs, use fission, that's splitting heavy atoms apart. But hydrogen bombs, H-bombs, use fusion, forcing light atoms like hydrogen together. And here's the key. To get the insane heat and pressure you need for fusion, you first have to detonate a fission bomb. So an A-bomb basically acts as the match to light the H-bomb's much, much bigger fire. The arms race hit its absolute terrifying peak in 1961 when the Soviet Union tested the Tsar Bomba. This thing was less of a practical weapon and more of a raw demonstration of power. It was the largest single explosion ever created by mankind. The yield was a staggering 57 megatons. That's 57 million tons of TNT. To try and put that into perspective, that's the same as over 3,800 Hiroshima bombs all going off in the exact same spot at the exact same time. The shockwave from this one blast literally circled the globe 3 times. Now, while no single bomb has ever matched the Tsar Bomba's raw power, today's weapons are in a lot of ways far more terrifying. See, it's not about one giant blast anymore. It's about precision, speed, and overwhelming an enemy with lots of different warheads. Today's arsenals are all about their advanced delivery systems. You've got the Trident II, launched from a submarine, which makes it pretty much undetectable, the DF-5, which can reach nearly any target on Earth, and Russia's RS-28, nicknamed Satan II, is designed to just bypass missile defenses entirely. But maybe the most crucial evolution is this. A single missile can now carry multiple nuclear warheads, and each one of those can be many times more powerful than the bomb that destroyed Hiroshima. To really understand the power packed into a modern weapon, let's just consider a scenario. Imagine a single missile carrying a 50-megaton payload, so similar in power to that Tsar Bomba, and it detonates over the heart of New York City. The result? Over 7 million immediate deaths. Not injured, not needing help, just gone in an instant. That's the power we're talking about, contained within a single modern weapon. So, this brings us to the ultimate question of the nuclear age, doesn't it? With thousands of these weapons out there capable of this level of devastation, why has a nuclear war never actually happened? The answer is a really grim paradox known as mutually assured destruction, or, appropriately, MAD. The logic is actually pretty simple. If one side launches a nuclear attack, the other side will still have enough weapons left to launch its own devastating counterattack. The result? Total annihilation for everyone. No one can win, so no one can start the game. And in our world today, while a few nations have nuclear weapons, the vast majority, we're talking over 90%, belong to just two countries, Russia and the United States. This two-sided balance of terror is really what holds up the logic of MAD on a global scale. And that leaves us with the central paradox of our time. The weapon so terrible it can never be used has, so far, prevented the very wars it was designed for. The standoff holds, but the question we all have to live with is, for how long? And what happens if it ever breaks?